Hello everyone, my name is Rajeev Lochan Panda and my partner's name is Bimal Kumar Behera. We are the students of National Institute of Science and Technology Bahrampur. We are going to present about our IoT project. The topic is IoT based home automation solution. Here are the contents of our presentation: C programming, Internet of Things, embedded systems, microcontroller, about our home automation control project, Arduino, PiximLab, Blynk IoT configuration, Arduino requirements, simulation image, Blynk app image, and the conclusion. C programming is considered as the base for other programming languages. That is why it is known as mother language. Here is the structure of basic C program. The first line is the header and the main part is the part which is executed during compilation. The variable declaration part is shown here. This is the body part and the last one is the return statement. Topics we learned in C programming: data types. There are different types of data types, that is int, char, float, double, boolean, modifiers and qualifiers, conditional and loops, operators, arrays and pointers, strings, function, storage classes, preprocessors. So the data types are integer, character, float, double, boolean. These are the basic data types we frequently use in C programming. The different types of modifiers include short, long, unsigned, and signed. Types of qualifiers include the keywords like const, volatile. In the storage classes include auto, extern, register, static. Operators are different types like relational operators, logical operators, arithmetic operators. The conditional and loop statements are if, else, while, do while, switch. These are some examples of conditional and loop statement. Arrays in C can be defined as a method of clubbing multiple entities of similar type into a larger group. These entities or elements can be of int, float, char or double data type, or can be user defined data types. Pointers in C are used to store the address of variables or memory location. We can use the star mark to define the pointer. In C programming, a string is a sequence of characters terminated with a null character. A function is a block of code which only runs when it is called. You can pass data known as parameter into a function. Functions are used for perform certain actions and they are important for reusing code. Define the code once and use it many times. All preprocessor commands begin with a hash symbol. So what is Internet of Things? The device which is dynamic and self-adapting, self-configuring, interoperable communication protocols are obeyed, unique identity and integrated into information network. Here is the picture which shows the different types of examples of Internet of Things. Applications of IoT: home automation, activity trackers, industrial security and safety, motion detection, health monitor. Embedded system is the combination of computer hardware and software for a specific design. Here is the structure: sensor, analog to digital converter, processor, digital to analog converter, actuator, memory. Sensor measures the physical quantity and converts it to an electrical signal which can be read by an observer or by an electronic instrument. AD converter converts the analog signal sent by the sensor into digital signal. Preprocessor and ASCII process the data to measure the output and store it to the memory. DA converter converts the digital feed by the processor to analog data. Actuator compares the output given by the DA converter to the actual output and stores the approved output. Here is the applications of embedded system: audio device, mobile modules, games, medical devices, sensors, vehicles. Microcontroller. The microcontroller consists of analog to digital converter block and digital to analog converter block, timers and counters, pulse width modulation, processors, memory and input output ports, different types of RAM and ROMs. Home Automation Control Project. The overview of our project is: this project provides an IoT based home automation solution using Arduino Uno board in PiximLab simulator. Blynk IoT mobile application is used to control the device remotely. This project we can control the LED lights, temperature of the home and inflow and outflow of water in the water tank. Connect the home appliances to the Arduino and integrate it with Blynk IoT app using Blynk Cloud. Control lights, temperature of home along with the level of water tank using mobile app and obtain the notification on the mobile phone. Why we need home automation? Generally, people always don't stay at home. This brings the problem of home appliances not being monitored. The solution for this problem comes out to be home automation. Home automation enables people to control most of the devices remotely, such as garden lights, temperature of home, volume of water in the water tank. Here is the picture of home automation control project. This is the PiximLab where all the connections are done. This is the Blynk Cloud server. This is the Blynk IoT mobile app, and you can control the home appliances by using this. Arduino. Arduino Uno is based on Atmega 328P microcontroller. The Arduino Uno includes 6 analog pin inputs, 14 digital pins, a USB connector, a power jack, and an ICSP header, that is in-circuit serial programming header. It is programmed based on IDE, which stands for Integrated Development Environment. It can run on both online and offline platforms. The picture shows the different parts of Arduino Uno. PiximLab. PiximLab is a real-time emulator of development boards with MPLABX AVR GDB debugger integration. PiximLab supports several devices spare parts that can be connected to the boards for simulation. This is the picture of PiximLab. Blynk IoT app configuration. In this internship project, we have understood how to create new template, how to add device, how to select and add data stream, how to create icons, and to include Blynk library in the Blynk IoT app. This picture shows the configuration of Blynk IoT app in the mobile. From this slide onwards, my partner Bimal Kumar Behera will explain other slides.
Arduino requirements: LED, LDR, temperature control system, serial tank, Ethernet shield, and the Blynk IoT app. LDR. LDR stands for High Dependent Register. LDR, it is a special type of register that works on the principle called photoconductivity. That means resistance changes according to the intensity of light. Its resistance decreases with an increase in the intensity of light. It is also called as a light sensor. Sudden light control. The properties of LDR sensor is applied to accomplish the controlling of garden lights. That means during the daytime, the outdoor light is maximum. So the LDR sensor detects the outdoor light and the garden light is turned off. Whereas at the night time, the outdoor light is very low. So the LDR sensor detects the light and the light is turned on. Temperature control system. Temperature is recorded using LM35 sensor. The temperature control system consists of heating registers, LM35 sensor and a cooler. The analog value of the temperature is obtained from the LM35 sensor and then it is converted into digital value which is displayed on the CLCD. The temperature system, that is the heater and the cooler, can be controlled using the Blynk mobile app. Here the temperature system and the CLCD is connected to the Arduino Uno, whereas the CLCD displays the temperature and the notification, whereas the Blynk IoT app is connected to the Arduino Uno and the heater and the cooler can be controlled, and also we can see the notification. Water tank control or serial tank. It reads the volume of the water in the tank through serial communication and display it on the CLCD. We control the volume of the water in the tank by controlling the inlet and outlet valve by sending commands through the serial communication and display the volume of water in the tank on the CLCD. Here, the water tank and the CLCD is also connected to the Uno, where the CLCD is used to display the volume of the water and the notification. And we can also control the inlet and outlet valve using the Blynk IoT app, and we can also see the volume of the water and the notification in the Blynk IoT app. Simulation image. It is the screenshot of the Pixim Lab simulator, where it consists of the LED, the LDR, CLCD, which displays the temperature and the volume of the tank, and a temperature control system and an Ethernet shield. And here is a screenshot on the mobile app or the Blynk IoT app. This image displays the temperature and a cooler switch or button and a heater button or a switch. And here it displays the notification. And this image displays the water volume of the tank, which is having a inlet valve and the outlet valve, which can be turned on or off. Conclusion. In this project, we have built the home automation system with the help of Pixim Lab simulator and the Blynk IoT app. Using Blynk IoT app and Pixim Lab simulator, simulated home automation where LED, temperature system, serial tank resembles light, heater, cooler, and water tank in the real time. So the user can easily use the Blynk IoT app and control the home automation from the mobile phone. Thank you.
I am Rajeev Lochan Panda. Here is my Arduino code and simulation. So this is the part of our code which are implemented in the project. This part is to connect with the Blynk IoT app on the mobile phone. This is the Blynk template ID, device name and authorization token. This is to set the LCD address to 0x27 for a 16 characters and 2-line display. This part is to control the temperature of our room. This is the code for cooler pin to turn on and turn off. And this is the part of heater pin to turn on and turn off from the Blynk IoT mobile application. This part is to turn on and turn off the inlet and outlet valve of the water tank from our mobile app. The update temperature reading is to display the temperature and volume of water on the LCD. To handle the temperature, if the temperature value is greater than 35, then the heater pin will automatically off, and to control the water level, if the water volume is below 2000, the outlet valve will automatically turn off and the inlet valve will turn on. If the water volume is greater than 3000, then the inlet valve will turn off. These are some initialization of function. This is to connect the Blynk IoT app. This is to initialize the LCD. This LCD.backlight is to turn on the backlight. This is to clear the screen. It is for the cursor of the home. Init LDR to initializing garden lights as output pin. This is the initializing temperature. LCD.set cursor to set the cursor on the CLCD. Temperature.set interval is to update temperature on the Blynk app for every 0.5 seconds. This is the part where the control of brightness of the garden lights using LDR sensor can be done. Tank volume is the volume to show the reading on the CLCD. Here the functions are defined. This is the LDR programming part where the glowing of LEDs are done according to the variance of resistance of the LDR. These are some pins and ports that are connected with LDR and LEDs. Here all the connection of the Arduino Uno board's pin displayed. Here is the serial tank programming code. In serialtank.h file, the connection of inlet outlet pins are shown. In temperature system programming code, the heater cooler pins are displayed and the temperature variation is calculated. 10 millivolt equal to 1 degree Celsius. This read the analog output voltage from temperature sensor and convert it to degree Celsius. In this file, the heater and cooler and the temperature sensor are connected to Arduino Uno according to their pin and ports. Here I export compiled binary file. The code is compiled successfully. Here I am uploading the hex file to the Pixim lab. In home automation control IoT project, we are using Pixim lab, and the spare parts of Pixim lab are LDR, LEDs, temperature system, Ethernet, LCD and serial tank. LDR is used to control the garden light. During the daytime, light intensity is more. According to LDR principle, light entering the LDR is inversely proportional to the resistance of sensor. So the resistance of LDR is low and LEDs are off during daytime. This is the scenario of daytime where the resistance of LDR is low and LEDs are off. In night time, light intensity is less and resistance of sensor is more. Because of this, LEDs are on during night time. This is the scenario of night time where the resistance of LDR is high and the LEDs are glowing. The LCD is used to display the readings or values of the room temperature and water volume in the water tank. The Ethernet is used for connection of all the parts. The blinking of light in the Ethernet shows that the Ethernet is connected. At the room temperature, the temperature is 27.34 degrees Celsius. To increase or decrease the room temperature, we are using Blynk IoT app, which enable an user to control it from mobile phone from anywhere. To increase the room temperature, we can turn on the heater button from the Blynk IoT app. After reaching 35 degrees Celsius, the heater is automatically turned off. To decrease the temperature, we can turn on the cooler from the Blynk IoT app. The cooler button will help to maintain the room at normal room temperature. Here is the simulation for the increase and decrease of the room temperature. Now the heater is on and the temperature is gradually increasing to 35 degrees Celsius. After 35 degrees Celsius reached, the heater is automatically turned off. To cool the room, we on the cooler button. Here the fan of the temperature system is moving and the temperature is fall down to normal room temperature. Here we got the notification that temperature is above 35 degrees Celsius, turning off the heater. The water volume is displayed on the LCD. The capacity of the water tank is 3000 liters. To control the flow of water into and out of the water tank, we are using inlet and outlet valves respectively. When the water volume reaches to 3000 liters, in that case, the inlet valve closed automatically. The outlet valve will work until the water level is 2000 liter. When the water level reaches below 2000 liter, the outlet valve turned off and the inlet valve will turn on. This process will help to store the tank at least 2000 liter of water. The Blynk IoT app enables an user to on and off the inlet and outlet valve according to the need. Here the water volume is 1960 liters. So to fill the tank, we are switch on the inlet valve, which shows that water level is increasing in the water tank and the volume of water is displayed here. We get a notification that water volume is more than 3000, turning off the inlet valve. So after reaching the 3000 liter, the inlet valve is turned off automatically. Here by turning on the outlet valve, the water level is decreasing and decreasing value is shown on the LCD. it is going below 2000, so the inlet valve is turned on automatically. Here we get a notification that water volume is less than 2000, turning on the inlet valve.
I am Bimal Kumar Behera, going to present the code for our project called Home Automation System. Here it is the authentication token, which is provided by the Blynk Cloud. So the first part of our project is to handle the temperature. So first we check if the temperature is more than 35 or not. If the temperature is more than 35 and the heater is on, we have to turn off the heater because it is not the normal temperature. So we are turning off the heater, and along with that we are displaying the notification on the CLCD as well as on the Blynk mobile app. So in the Blynk mobile app, we are displaying as temperature is more than 35 degrees Celsius, so turning off the heater. And the next part of the project is to handle the tank or the water tank. First we check if the water volume is less than 1900 or not. If it is less than 1900 and the inlet valve is off, we have to enable the inlet valve and we have to display it on the CLCD as well as on the Blynk app. On the Blynk app, we are displaying it as water volume is less than 1900 liters, so turning on the inlet valve. And if the volume of the water in the tank is equal to 3000 and the inlet valve is on, we have to turn off the inlet valve, and with that we have to print inlet valve is off on the LCD as well as on the Blynk app. So we are displaying it as water tank is full and turning off the inlet valve. So here is the demo of the project. So it is the LED, then this is the LDR, and this is the CLCD, which displays the temperature and the volume. And this is the temperature control system, and it is the Ethernet shield. First, we connect to the serial tank, and then let me load the X file. And now the tank is getting filled, and we can see the notification on the CLCD as well as on the Blynk app. And we can also see a notification on the Blynk app that the water volume is less than 1900, so turning on the inlet valve. Now the tank will be completely filled. Now the tank is completely filled, so it has stopped or the inlet valve is turned off. Now if we want to decrease the water, we have to turn on the outlet valve. Now it displays as the outlet valve is turned on. Now we can also see that the when the tank got completely filled, it got a notification that the water tank is full and turning off the inlet valve. And now the tank volume has reached less than 1900, so the outlet valve got turned off, and you can see the notification that the water volume is less than 1900, so turning on the inlet valve. So it will now again fill the water in the tank, and it will again reach to the maximum capacity. So we got the notification that the water tank is full, so turning off the inlet valve. So this is the first part of the project. Then and the next part is the temperature. So now the temperature, when we turn on the heater, the temperature rises, and you can see the heater is on. and when it reaches 35 degrees Celsius, so it heater is turned off, and when we turn on the cooler, the temperature is getting decreases, and when we again turn on the heater, it rises, and after going 35 degree, we can see the notification that the temperature is more than 35, turning off the heater. And when we again turn on the cooler, it is cooling down the temperature. Thank you.